Okay, so hello and welcome. We're going to start our first example of tree diagrams. Now, tree diagrams are particularly useful when you are not interested in one outcome but interested in a series of consecutive outcomes, or simply interested in more than one outcome, right? So examples of this is if I have to select two boys from a team at random followed by one girl, or I have to draw more than one card from a deck, or I will take a coin and I'm going to toss it more than once. So what we're going to do is we're now going to look at an example of this type of tree diagram, and we will list our tosses over here: toss 1, toss 2, and toss number 3, right? So the question reads, a coin is tossed and a head or a tail is recorded. Find the probability of getting two heads, that means there's at least two tosses, and a tail, that means there's a third toss, in any order. So I'm going to start over here and I'm going to say, okay, right, in the first toss, I can either get a head or I can get a tail. And let's record the probability. Because there's only two possible outcomes, you already know that you're either going to get the probability out of a space of 2, so it's going to be 1 over 2. For a tail, it's also 1 out of 2 because there's one tail and there's two possible outcomes. And then in your second toss, you can either get a head or a tail again. Okay? You can either get a head or you can get a tail. And in this second toss here as well, you can either get a head or you can get a tail. Now, in each of those cases, you know the coin hasn't changed, so the probability remains 1 out of 2 for each of those occurrences. And then in the final toss, you could once again follow that up with either getting a head or getting a tail, getting a head or getting a tail, a head or a tail, and a head or a tail. Okay, so again the coin hasn't changed, and in this toss I've got 1 out of 2, 1 out of 2, 1 out of 2 possible occurrences, 1 out of 2 possible occurrences. Okay, now what happens when I get the probability of these sort of things on a tree diagram is I multiply across. And now we're going to teach you about how to look at this. So if you see over here, clearly I'm going to ask you for the first possible outcome, which is a head, and another head, right? Which is this branch over here, leading into this over here, and leading into this over here. So the probability of getting head, head is a half multiplied by a half multiplied by a half, which is 1 out of 8, right? There's 1/8 of a chance of getting that. The probability of getting a head, and tail now, which is H, T. Just work with me. I'm going across this branch there, then there, now the second one over here, which is also 1/8. Okay, the third one is head, tail, head. Probability of getting a head, tail, head is 1 out of 8. I'm going to leave out the commas now for the sake of brevity. Head, tail, tail is equal to 1 out of 8. Now it's not always going to be equal. It's just our example here now that everything is going to be equal because everything remained a half for any of the likelihoods over here. So probability of getting we've done head, tail, head, tail, tail. We're now going to the tails, right? So we have tail, head, which is equal to a probability of 1 out of 8. Then the probability of tail, head, tail is also 1 out of 8. The probability now of tail, head is 1 out of 8. And then we have one more to go, and that's the probability of tail, tail, tail. Okay. Now, here they told me find the probability of getting two heads and a tail. This means in any order. So the probability of getting two heads and a tail, I'm just looking for H, T. So there's the one, there's two heads and a tail, right? Is there another two heads? Head, tail, head. There's another two heads. There's only one head. There's two heads. There's one head. There's one head. There's three heads and no tails. So the probability of getting a two heads and a tail is going to be 1 over 8 plus 1 over 8 plus 1 over 8. If the order didn't matter here, as you can see, this means in any order. So the probability of getting HHT, let's two heads and a tail, in any order, will be the probability of this, which is equal to 1 out of 8 plus 1 out of 8 plus 1 out of 8 equals 3 out of 8. Now this could get you thinking about the lotto, and if, for example, because order matters, what was the probability in the lotto, for example? What would be the probability of getting two heads and a tail in that specific order? Now your chances are much slimmer because it's a 1 in 8 chance. But if the order didn't matter and you had to get two heads and a tail, you can clearly see that you've got a 3 in 8 chance. If I told you you must get two tails and a head in that specific order, your probability of getting that would be 1 out of 8. And so that's the first example of a tree diagram.